All right. So we are now moving from parametric equations to polar equations. And polar equations are really, really fun. But it is totally different than anything else you've ever studied. I don't know if you did much polar stuff or if you did any polar stuff last year in your pre-calc class. So we'll just have to see what you think of polar. Well, not last year in your pre-cal, but 2 years ago in your pre-cal, right? So this first lesson will be just what are polar coordinates. So whether you did it or not, this is your refresher, or it'll be new to you of what polar coordinates and equations are, so that you know how to do the calculus when we get there. So this is another introductory lesson on what are polar equations and how do you graph them and what does it all mean. Okay, so this is an introductory lesson on the pre-calc part. So our outcome is I can sketch a polar equation. I can convert between polar and rectangular. Rectangular is your normal x and y Cartesian coordinates. And then determine the Cartesian equation if we want to know an equation for a polar curve. All right. So again, this is your introductory information about polar coordinates before we even get into the calculus part. So just general information about it. Okay, so what is polar? Polar is where you graph like you do on the unit circle, okay? You start on the right-hand side and you graph a point by a certain rotation angle around, and then how far it is from the pole, just like on the unit circle. So when you do the unit circle, and we talk about this being pi over 3, all right? Pi over 3 is the angle of rotation around to that point, okay? So that is your angle theta. That's your theta measurement. Now, that's actually the ordered pair 1/2 radical 3 over 2. But this is your Cartesian or your rectangular coordinates in x and y. The polar coordinate is an r comma theta. So if I were to write that ordered pair as a polar coordinate, the angle theta is the pi over 3. And the r value is your distance from the origin, which is called the pole. All right, so we know this is a unit circle, so we know our radius is 1, so that would be the point 1 pi over 3. All right, so it is an ordered pair with respect to the origin, okay, which is called the pole in polar coordinates. All right, it is an ordered pair r comma theta, theta being the angle starting from the positive x-axis and going counterclockwise. So it's your theta degree angle rotated around the pole, around the origin. And then your r is this distance to the point from the origin. So in this case, so on your unit circle, r would be 1 the whole time because that's how far every point is from the origin, because this is a unit circle with radius 1. All right, so r is your distance from the pole, which is the origin, and theta is your angle with respect to the positive axis. All right, so polar coordinates are the distance from the pole, comma, the angle of rotation, like going around the unit circle. All right, so now, in polar coordinates, a point can have multiple representations. All right, it can have multiple representations. So for instance, the point 2 comma 30 degrees. That same point can be 2 comma negative 330 degrees. So when you think about going around, you could go positive 30 degrees and then be 2 units from the origin. So that would be 2 comma 30. Or you could go negative 330 and then go 2 units out from the origin. So this is the same thing as going 2 units and negative 330. All right, so I would start here at the positive x-axis. I would go negative 330 degrees around, and then I would go a distance of 2 units out from the origin. So that point has those two same representations. All right. You could also go negative 150. Well, negative 150 means negative 150. All right. So I would go this way, 150. But then I would need to go negative 2. So instead of going 2 units out from the pole towards my 150, I would go negative 2 in the opposite direction. Now, I know that's a little crazy to think about going the negative direction. But if I go 150 negative, so negative 150, that's going to put me on the axis over here if I go out positive 2. But I want to be on this side, so that would put me at negative 2 going on the opposite direction. So if I go around the pole 150, this ends up being the positive end. So I go negative 2 out this end. This is my negative end. This is what I'm talking about. All right. You could also go 390 degrees and go out 2 units. So I could go around 360 and then 30 again. So that's going to be 390 and then do 2 units. Or I could do 210 and go negative 2. So I could go around 210 degrees and then go negative 2. So notice I could do either negative 150 or positive 210 and then go negative 2 in the backwards direction. All right. So these are all the same point in polar. So you can go a positive or negative angle measure, or you could go a positive or negative distance from the pole. Okay. And then here's what it is in radians. You can go your angle minus 2 pi. You can go your angle minus pi. You can go your angle plus 2 pi. So these are the different orientations. Now, I also showed it. This is in degrees. I did it in degrees here, but I want to show you these are the same points. These are the exact same points that I just did, 2, 30. These are in radians. So this is the same points just written in radians. So 2 pi over 6, 2 negative 11 pi over 6, that's your negative 330. All right, remember pi over 6 is 30, and then 30 times 11 is 330. So remember how we did that. Pi over 6 is 30 times negative 5 would be negative 150. Okay, so these are the exact same ordered pairs. I just wrote them in radians. Okay, so all 5 of those points represent the same point, on the polar grid. Now, the polar grid, that didn't keep it still for me. All right, your polar grid is where you do like on a unit circle. We're going to go pi over 6, which is 30 degrees, so pi over 6, and then I'm going to go out 2 units. So this is the point 2 comma pi over 6. So I went 30 degrees up, and then I went 2 units from the pole. All right, so that's the same ordered pairs just written in radians. All right, so that's what polar coordinates are. Polar coordinates are r comma theta. Theta being the angle that you rotate around in the counterclockwise motion when it's positive. And then r is your length of your distance from the pole or the origin. Okay. Now, this tells us how to go. These are the coordinates or the conversions to go between polar and Cartesian. All right. So we know if I have a picture, here's my picture here. If I start on my positive x-axis and I have a point that is a theta rotation with a distance of r, we know that our coordinates are x comma y. Okay, so like the one I just did with the 2, well, I did 2 comma 30. We know 30 degrees is pi over 6. And then its distance from the origin would be the 2, would be the r. Now that point has an x and a y coordinate. All right, so that comes from your x coordinate is how far over and your y coordinate is how far up. Now we get those coordinates when we have a radius of 1. Those are actually the unit circle. So if you have a radius of 2, how do we get those values? Okay, so think about it from this standpoint. I'm looking at this triangle. I know the cosine of theta. Cosine is adjacent over hypotenuse. Think about that from geometry, remember. Cosine is the adjacent over the hypotenuse. So we know cosine is x over r. Now your sine is opposite over the hypotenuse. So that would be y over r. Okay, so these values up here just come from your geometry. Cosine is adjacent over hypotenuse, sine is opposite over hypotenuse. So looking at this triangle, we're trying to figure out the coordinates of x and y, even when r is not 1. We know what it is when they are 1 because that's the unit circle. So how do you get it when they're not, when r is not 1? Okay, so cosine x over r, sine is opposite over hypotenuse, y over r. So now all you do is solve for the x coordinate. So you just multiply r to the other side. So here is the equation you need to know. So your x coordinate is r times the cosine of theta. Your y coordinate is r times the sine of theta. Now when we do the unit circle, r is 1. So x is the cosine value, y is the sine value. But if you're not doing a unit circle, if you're doing a radius length that's not 1, then this is how you find your x and your y coordinates, okay? Now, notice using this as a right triangle, you'll notice that we can do Pythagorean theorem, x squared plus y squared equals r squared, because this is a right triangle. And notice that the tangent of theta, tangent is opposite over adjacent. That's again from your geometry class. Tangent is opposite over adjacent, so tangent is y over x. So these are 4 equations that you need to know to be able to convert between polar and rectangular, which is your regular x and y Cartesian coordinates. So those are the 4 equations that you will need. So you will need to know that your x coordinate is r times cosine theta. Your y coordinate is r times sine theta. And you have to use this sometimes, that r squared is x squared plus y squared. You use that a lot when you're converting back to Cartesian, or back to polar, excuse me. And then tangent theta is y over x. You use this one a lot too when you want to convert back to the polar, okay? So these you use to convert to rectangular, these you use when you convert back to polar. All right, so we'll just make sure we have those. So we're into examples. I'm going to do a few examples before I split off and go to a second video. I'm first just going to plot some points just to make sure we understand how to go back and forth between, or how to graph and so forth. What polar is. So this is what a polar graph looks like. A polar graph is circular. Okay, it's not rectangular. It's not a rectangle, which is why it's not rectangular. Okay. It's a pole, it's polar. So polar graphs are in circular form. So when we're graphing these problems this time, you're going to have graph paper that looks like this, all right? Well, not that you have to go buy any, but you're going to have to draw on a circular picture. So I don't know if you'll need to have a printer or whether you just want to have, sketch these little polar things out. We'll have to see as we go along since we are doing this virtually, okay? So plot the points whose polar coordinates are given. Okay, so we want to plot 1, 5 pi over 4. So where is 5 pi over 4? So remember, pi over 4 is 45, and then times 5, that's going to be 225. So if you look at this grid here, these are spaced out in 30s. So this is 30, this is 60, this is 90, this is 120, 150, 180, 210, 240, 270, 300, 330, and then back to 360, which is 0. All right, so these are in groups of 30. So where would 5 pi over 4 end up? All right, so 5 pi over 4, like I said, is your 225. So 225 we know is in the middle here. Okay, and then it's going to be 1. So these are your units. These circles are your units out from the pole. So if I want to be 1 unit and at 5 pi over 4, I'm going to go around to 225, which is in the middle here between 210 and 240, and I only want to be 1 unit out. So that's the dot right there on the first circle. So this first circle is 1 unit out. Okay, so that's the first one. Now the next one is 3 pi, and I want to be 2 units out. So 3 pi, well, we know 2 pi is going all the way around, and then another pi puts me here at 180, and then I want to be 2 units out. So 2 units from the pole puts me right here. Okay. Now I want to be negative 2 pi over 3. All right. So negative 2 pi over 3. So pi over 3 is 60. And then times negative 2 is going to put me at negative 120. So negative 120 is the same as positive 240. So I'm going negative 120. And then I'm going to be at positive 2. So I'm still going to be on this side. So I'm going to be at positive 2. So I'm right here. So I'm going negative 120. And then I'm positive 2. All right, so we've done that one. So now I want to be 3 pi over 4, and I want to go negative 3. So 3 pi over 4, if you remember, pi over 4 is 45, times 3 is going to be 135. So I want to go around to 135, which is in the middle here between 120 and 150, so 135. But I want to be at negative 3. So if I do 3, I'm going to be on this side. So negative 3 puts me over here. So I want to be on the third circle out, but I want to be on the opposite end of this axis because I've gone around to 135, which is 3 pi over 4, and then I want to be on the negative side. This is the positive side. When I'm at 135, this is the positive end of the axis, so I want to be on the negative end of the axis. I want to be on the negative end of the axis, so negative 3 is going to be on that side. All right, so if I graphed positive 3 pi over 4, I would be on the third circle right here on this end. All right, so you want to make sure you're going the right direction as far as positive and negative, and then once you find that end of your, when you get your angle, you find that end of your axis, that's your positive end. So if you're graphing positive, like we did on those first 3, you want to stay on that end of the axis. But if you're graphing negative, you go to the other end on the opposite side of that axis. All right, so I hope that helps. Hope you understood what I'm saying. All right, on this one, I want to convert the point 2 pi over 3. I want to convert it from polar to Cartesian coordinates. All right, so right now this is r and this is theta because this is the polar coordinate. I want the Cartesian coordinates. So I want my x, comma, my y. Okay. All right, so the way to do that, I know my x is my r cosine and my y coordinate is my r sine. So all I got to do is fill them in and work it out. So my x coordinate is going to be my r value times the cosine of my angle, which is pi over 3. So that's going to be 2 times what is the cosine of pi over 3. So think on your unit circle where pi over 3 is. That's your 60 degrees. All right. So that's your 60 degrees. So you're over a little and up a lot. And your cosine is your x coordinate. So that's going to be 1/2. So that means my x coordinate is 1. So now to do my y coordinate, I'm doing my r value 2 times the sine of my angle, pi over 3. So that's 2 times the sine of pi over 3. So the sine is the y coordinate, so that's going to be your radical 3 over 2. So the 2's are going to cancel, so my y coordinate is radical 3. So that means my ordered pair in rectangular is going to be 1 comma radical 3. All right, so let's just use this and graph this and see how we did here. All right, if I have this in polar, this means I'm going to find pi over 3, which is my 60 degrees. So this is 0, 30, 60. So I'm on this end of my axis, and I'm at 2. So I'm on the third, so I'm on the second ring, so I'm right here. So now my coordinates using rectangular means I would go over 1 unit, and then up square root of 3. So this right here is not quite 2. Square root of 3 is 1.7. So this is the coordinate over 1 up square root of 3, which is about 1.7. And you can tell that the y coordinate on that, this circle is at 2 because this circle represents the second ring. So up here's 2, but my y coordinate of this point in x and y coordinates in rectangular is not quite at the up high enough on the 2. It's going to be at 1.7. So this is the rectangular coordinates. These are the polar coordinates. Okay. This one says convert the point 1, -1 from Cartesian. So this is your x and your y. We want polar coordinates. Okay. We want polar coordinates. All right, so that's where you're going to use that r squared is x squared plus y squared, and you're going to use that your tangent of your angle is y over x. Okay, so that's where you're going to use that. All right, so our r squared is going to be my x squared plus my y squared. So that's going to be 1 squared plus negative 1 squared. So r squared is going to be 1 plus 1, which is 2. So r is going to be radical 2. Then over here, I'm going to do my tangent of my angle is y over x. So negative 1 over 1, so that's negative 1. So I've got to figure out the tangent is negative 1. So I've got to think, where does that happen on the unit circle where my tangent value is negative 1? Well, that's where your x and y values, your x and y's are opposite signs. All right, so that when they cancel, they're going to give me a negative 1 answer. So where do we have opposite signs? So that's going to be in the second and the fourth quadrants, in the middle, right? So that's going to be at 3 pi over 4. And then over here in the fourth quadrant where you're positive negative, that's going to be 7 pi over 4. So we got to figure out which ones are answers, all right? How are we just going to put these together? Is this going to be radical 2, 3 pi over 4, radical 2, 7 pi over 4? You need to figure out what goes together here. All right, so think about this. Where are you if you're at 1, negative 1? So if I'm at 1, negative 1, I'm about here. So I've gone over 1 unit, and I'm down 1 unit, matching down here with this bottom of this circle. So I'm right here. So where am I? I'm at 7 pi over 4. This is around 7 pi over 4, right? And I've come out more than 1. I'm past the first circle, which is square root of 2. So I'm out 1.4. So I can put square root of 2 with the 7 pi over 4. And that's why it says be careful. All right. Now, how could I represent that same point using the 3 pi over 4? All right. So if I only went 3 pi over 4, which would be right here, to get to this point on this side, I'd have to use negative radical 2. Okay? So there's 2 points in polar that represent the point 1, negative 1. So I could either go around 7 pi over 4 and then go out the square root of 2, or I could go 3 radical 4, which is only 135, but then I'd have to go negative radical 2 to get to the other side. Okay? You could also go negative 3 pi over 4 and do positive radical 2. All right, some of you may have been thinking that. What if you go, wait a minute, that wasn't right. What if I go negative 1 pi over 4? I shouldn't have just done 3 pi over 4. Where'd my pen go? Here it is. All right, let's see. Because some of you may have been thinking, well, what if I go the negative way? I shouldn't have put negative 3. My pen will work here. Come on. All right, not negative 3 pi over 4, negative 1 pi over 4. So if I want to go start here and go the negative direction, I would just need to go negative pi over 4, and then I would stay on this end, and I'd be able to keep the positive radical 2. All right, because I would be on this end of my axis. I'd be on the positive end. So you would go negative pi over 4, then you'd be on your positive end of your axis, and you could do radical 2. So you could represent this as negative pi over 4 because you're doing going the other way than 7 pi over 4. You're going negative pi over 4 and then radical 2. All right, so you could do that one too. So remember, there are multiple ways to represent these points. There's lots of possibilities on this. All right. So this problem says, what curve is represented by the polar equation r equals 2? All right. So if r equals 2, what curve are we talking about? So r equals 2 means it doesn't matter what angle I am on, I'm always 2 units from the pole. So if you're always 2 units from the pole, you're always out 2 units from the pole, no matter where you are, right? You're always 2 units out from the pole. So I'm always out here on this second ring. So what is this if you're always out here on this second ring? That is a circle, all right, with radius 2, right? So that means r squared is going to be 4. So that means my equation is x squared plus y squared equals r squared, which is 4. So this is nothing but a circle centered at the origin with a radius of 2. That's all it is. All right. So what curve is represented by the polar equation r equals 2? That just means I have a radius of 2. So I'm a circle centered at the origin with a radius of 2, which is x squared plus y squared equals 4. That's the Cartesian equation. R equals 2 is the polar equation, because that's all you need to say when you're in polar. You just need to say that your radius from the pole is always 2. But in Cartesians, we're using x's and y's, so this is your rectangular or your Cartesian equation, that it is x squared plus y squared equals 4, because the r squared is 2 squared, that's 4. So that's your circle with radius 2. All right, one more and I'll quit this video and then have us do something else. All right, this one says sketch the curve that says theta equals 1, okay? Theta equals 1. So this means you're sketching the polar curve where the angle is always 1 radian. And then here in this parentheses here, it says 1 radian is about 0.32 pi, which that's close to 0.33, which is close to 1/3. So this is really close to pi over 3. Really, really close, okay? Really close to pi over 3. So we're sketching the polar curve theta equals 1, which is really close to pi over 3. So this says we want all r's when you're pi over 3. All right, so pi over 3 is 60 degrees. We're just under 60 degrees, so I wouldn't have to do right on the 60 degrees, but I want every r value, so that's this straight line. So that's that straight line where we're going here from 0, we're going around to pi over 3, or almost pi over 3, since this is just under pi over 3. So, and it doesn't matter what my r is. So I could be 1 unit from the pole, 2 units from the pole, 4 units from the pole, 5 units from the pole, or I could be -1, -2, -5. So that's this straight line. So if you just have the angle, it's a straight line. All right, so what would theta equals 5 pi over 6 look like? Okay, so 5 pi over 6, we just have to find 5 pi over 6. Well, pi over 6 is 30. 30 times 5 is 150. So we're talking 30, 60, 90, 120, 150. So we're right here at 5 pi over 6. So that's this line right here. So that means we're including all r values. So you're wanting every r distance from the pole at this angle, 5 pi over 6. So you want the positive side and you want the negative side. So that makes a straight line. So anytime you're asked to graph theta equals, it's a straight line. If you're asked to ever graph r equals, that's what ring you're on. You're on ring number 2. That's your r, which is a circle. All right, and so this is where I'm going to pause the video, because to do the next group, you really want to look at a handout that I've given you to talk about graphing all the different functions. So we really want to do that and make sure we understand what all the function names are and how to graph polar curves that have different sines and cosines and numbers in it. So for right now, we're just understanding what polar is and how to convert back to Cartesian rectangular. All right.